I don't want to compare importance, but everything is important and everything is exciting. So tracheal mites in honeybees. Okay. Ascarapis woodii, discovered in early 1900s in England, and North America, including Mexico, was free for most of the part of the last century, but in 1980s was first seen in Mexico, then in 1984 in United States, and from United States was spread to Canada with queens and bees. So a bit of life cycle: mated female enters the largest thoracic spiracle just under the base of the forewings of the young honeybee, usually a few days old. Once inside, the trachea will feed on hemolymph, will lay eggs, reproduce, and female daughters mated will come out and will reinfect young worker bees, drones, and queens. Everybody could be affected. So here is a diagram, and basically thoracic spiracle. So spiracle are ostia opening along the thorax where tracheal network is connected to the outside. So basically it is the way how bee is breathing. And the first pair of the thoracic spiracles are the largest ones. That's why they are exploited and used by this tracheal mite. They enter, and when you remove head and remove small portion of the collarette here under the dissecting scope, and when you look at the beehive frontally, so right now head is away, we can see these V structures here in the thoracic cavity that are trachea, and this pigmentation indicates that there was or is still infestation by the tracheal mites. Very similar condition for pathologists we have in some other species. And if I told you that this histological section comes from rhesus macaque, probably you would diagnose it as pulmonary acariasis. And very similar, we have this also pigmentation there. We have scarring and inflammation. In bees, inflammation is much less pronounced. We do have some cellular infiltrates and some melanosis, but not as a severe inflammatory reaction. So during the late spring and summer, we have short lifespan of the workers. So there is a high turnaround. Therefore, infection in the hive is relatively low. So we have only 5% infection, and usually we don't see effects. If it is higher, we will or would. In late summer and fall, infection starts to grow, and it can reach up to 60% in October in certain areas. Drifting bees and drones spread mite infection from colony to colony. So during the summer, usually no detectable effect. However, during the winter, these tracheal mites are known to affect clustering of the bees. And since winter in Canada is harsh, cluster is extremely important for survival of the queen. And if there is a disturbance of clustering and function of the clustering, in that case, there will be detrimental effect and high winter losses. So even low percentage of infection will have effects on overwintering because clustering is not going to be tight and temperature is not going to be high enough to protect queen. Very important. Having said so, we do not see a high prevalence of tracheal mites, mortality, or at least it could be two things. It could be that we don't test enough, but the second thing is could be because we use quite heavy artillery against Varroa, and many acaricides or miticides used for Varroa mites have effect also on tracheal mites. So they are keeping tracheal mites population low. Basically, we don't have, so now brood versus adults, obviously tracheal mites is strictly adult disease and predominantly young adult. And it is very difficult to diagnose it. There are some evidence like K-wing. So bees do not have separate wings. They are connected together, but K-wings, it's not specific. We can see it with nosema. We can see with some other infections. Weak colonies in the spring and slow build up and high mortality over winter. How do we diagnose it? We need to dissect it, as I said, under the scope, certain amount of bees in order to make it diagnostically relevant. So it is quite labor-intensive diagnosis. And this is probably the most labor-intensive diagnosis. And thank goodness that we don't have as high prevalence. But again, hopefully we are not missing by not testing. So K-wing, here it is, a K-wing. This is more normal condition of the wings versus this is K. Even though this wing has tapered edges, ragged edges, which indicate that this forager is probably already old. So what is K-wing? Is the wings on each side, they are hooked with this hook, and when these hooks are unhooked, this disappearance. How tracheal mite causes this, it's not known, but it is associated with certain diseases. Again, here is close up. In this particular case, we have on your right trachea that is clean, and on your left, both tracheas are infected with these tracheal mites. Breeding of honeybees resistant to tracheal mites is efficient control, and there is backfast bees that are more resistant, Russian bees. Ontario mite resistant bees in Canada, there was a quite successful breeding program. For the control, there are some non-synthetic control. Basically, if you put oil patties with oil in, the bees are a bit more greasy, and this is actually interfering with the transmission of the mites. So this is one of the non-synthetic or non-chemical control. However, there are many other controls that are used for both Varroa and effective also against tracheal mites. And I was supposed to mention that at the beginning. There was a question, how about Thymol? Is it efficient for Varroa? Yes, there is Thymowar, even commercial product that you can use for Varroa. Thymowar is not as efficient against the tracheal mites. Menthol is, menthol vapor, and menthol vapor will kill both tracheal mites and Varroa mites. But again, it's dependent on the temperature and it needs a prolonged exposure. Formic acid, we already spoke about formic acid for Varroa, is efficient also for tracheal mites. Amitraz is also efficient, apparently, against tracheal mites. So this is probably the reason that we don't see tracheal mites as big problem, because we are trying to suppress Varroa proliferation and Varroa problem and keep Varroa under the economic threshold of effects. You can watch various videos about tracheal mites, educational video. Jamie Ellis did and he has a series of videos that are very interesting. Now, I said there are 3 parasitic mites in honeybees, but only 2 in North America, and the one if sarcastically and black humor use, is pending. And the regulatory agencies are very, very aware of that. And if there are any suspicion, please contact veterinarian or your state apiculturist for Tropulelabs. Why at this stage probably Tropulelab mites global spread is not very likely. However, it is spreading. It is in the area of Eastern Asia, in the region of the southern subcontinent, India, Pakistan, and probably South China. It's spreading there. Difference between Tropulelabs and Varroa is basically that Varroa is a parasite of both phoretic stage and reproductive stage of honeybees, so in brood and in adults. Tropulelabs, for now, it is thought that it is brood parasite. So for at least Canadian beekeeping, where we have certain periods without brood, Tropulelabs will not survive, according to current understanding. However, it seems that it is spreading, and it seems that it goes in the area that potentially should not be there. So we don't know whether it is adapting a new survival strategy or whether we don't know everything about this mite. So in case that our original knowledge is incorrect, we will have trouble with Tropulelabs. In case that it can also feed on the adults, because it is much faster than Varroa, it moves faster, it reproduces faster, and it will cause bigger economic losses. So let's hope that we can still keep it there, and that our current understanding will protect us, or rather our current ignorance will not hurt us. This is not here. Okay. So right now, I will be trying also to catch up with certain things that I missed. So I will still do very brief overview of viruses, but basically, it is very true that we know very little about them. And current management of the viruses and prevention is to try to eliminate vectors. And here we have in the middle row list of viruses, and on the left side we have Varroa and Nosema that are considered to be vectors. So if it is in brown brackets, it's Varroa vector for these viruses. If it is in blue, it is Nosema considered to be. So if we control these two diseases, we should be indirectly controlling for all these viral diseases. However, jury is still out, and we know very little, and no surprising. We don't know very much about COVID, or we didn't know much about it just a short time ago, how would we know about all these viruses in bees? We do know very well about deformed wing virus, that it is actually very pathogenic. It affects all castes and all ages of the bees, but in pupal stage, it has a very distinct appearance and cause deformities of the wings. And it is worldwide distribution, affects all the stages, can kill pupae. However, if they survive, they will have either deformities, or if they don't, they could be affected by shorter survival life and compromised performance. Varroa mites is the vector considered to be the major vector of deformed wing virus. There are some new scientific work on various types of Varroa, various types of deformed wing virus. I'm not necessarily up to date. It's not our focus of the research, but there are some good papers on this. Regardless, controlling Varroa will reduce deformed wing virus. Even though I said it's not necessarily the main focus. We did publish, Roman Kuzi published a short study, and Ivana referred to it. And here is basically deformed wing virus from the same colony. These bees are not affected, and they are more, and even their viral load was very low compared to these. These were affected, viral load high. So these bees are presenting with certain symptoms previously described as parasitic mite syndrome. But we see it actually in also these heavily infected Varroa by deformed wing virus, which is transmitted by Varroa. So we see Varroa too there. And this is either male in newly emerged or immature female there, most likely, but I don't know. There are some things that are peculiar there, and we were studying quite extensively. We noticed that these bees that are infected with deformed wing virus, they have protruded tongue, very similar to PMS, but they sometimes take, not sometimes, they take much longer time to get out from the cell. And sometimes they even die like that. So we were wondering if this deformed wing virus is causing deformity on the wing due to something more than just wings. So we did multiple section of the thorax. We were wondering, could it be, since we have 3 pairs of legs there and we have wings there anchored, and if these are coming out and have difficulties to come out, whether we have effects of virus on the thoracic musculature and some kind of hypoplasia. But we did not do morphometric study on that, but we did do quite a few sections of the thorax and compared these samples and didn't see any effects. Nevertheless, these bees are less agilent and more difficult, and live shorter and cannot fly, obviously. Ivana spoke about this very nicely about these brood glands. I'm not going to be dwelling on this, but there could be effect on colony, indirect effect through the suboptimal care of the brood, as well as suboptimal care of queens, because workers are taking care of queens. And if queens are not taken care well, we will have poor quality of queens. But it's poor quality due to workers, in this particular case, infected by deformed wing virus. So complex situation. Another virus, sac brood virus, was discovered actually early 1900. It's not a big disease. It's more considered to be similar to the chalk brood. We see it in stressed colonies, and basically what we see, larval death and sac larval tissue is replaced by this fluid that is filled with viral particles, sac-like skin. If larvae are not dead or don't die due to this infection, the adults infected will have shorter survival time. And you can see that in colonies, stressed colonies. Paralytic viruses, you can see sometimes these bees, black bees that are bold. Sometimes you can even see paralyzed bees in front of the hive. They certainly have effect on the overall condition. Are they enough to kill by themselves? Probably not. It's almost like flu in people or in students before the final exam. Suddenly we have students with flu or herpetic erosions due to herpes virus, due to stress. So black queen virus or black queen cell virus is associated. So previous viruses are associated with Varroa. So keeping control on Varroa, we'll keep on those. This is associated with Nosema. And with any virus, keep vectors down and requeen if possible with good genetics. And that's probably the best what we can. Here is an example of natural queen cells as well as queen cells that are used for this artificial reproduction and multiplication of the queens affected by black queen cell virus. We had shortened session on physical exam, and here are some links that you could watch for the how to examine normal hive, physical exam of normal hive. And next session was supposed to be done before in the session that was due to technical difficulties, but I think it is very important, so I'll stick it here. And this is basically finishing about health of the colony, as well specifically health of the queens. So healthy colonies typically has one queen, drones during the summer, and ten of thousands of bees. Queen is laying eggs. There is this, we spoke already many times, synchronous brood and nice comparison between open and capped brood. Sufficient source of nutrition, polyfloral or multifloral pollen, and between the May and September in our areas, temperate climate, where we use two brood chambers, it is between 8 and 14 frames of brood that we'd like to see there for the healthy colony, and this includes open and closed brood. So now, queen health, very, very important, because as you saw in the stressors of the honeybees that contribute to mortality, poor queen quality was quoted quite often by beekeepers. You don't really need to find queen in order to determine its health. You look at the eggs, you look at the synchronous age and amount of the brood, and most importantly, you look at the absence of supersedure cells, because bees, worker bees, bee colony will be first to notice that something is wrong with the queen and we need to replace it. And those are supersedure cells. So remember, we spoke about swarm cells. So if the colony is healthy, it progresses, it proliferates. So whenever you're examining colony in May and June, it's must to examine for the swarm cells. If you have two supers or two chamber brood, if you have two chambers for brood nest, easiest is to see queen cells in between top and bottom chamber. You open it, you see a strong colony. Right now you see nothing there, but you smoke it gently here. These are going to go inside to the frames, and suddenly these queen cells or swarm cells at the periphery of the frames will show up. This is an alarm for you that you may be losing very soon in this case, because we have some cells that are being closed and early closed cells. This colony still didn't swarm, but it will if you don't act on it. And I'm not going to go through what various management systems. Go there and read about those, how to prevent swarming. But it's very important. Probably 1 week ago to 10 days ago, this colony should have been given more space, for expansion, because it was crowded and it started to feel that there is not enough space. Second thing that could be issue here is old queen or older queen. We used to have queens lasting in 4 and 5 years. Right now, recently, I recommend that the longest lifespan that I know in our area is 3 years. Many beekeepers change every second year. Ontario beekeepers, many of them change every year, and some of them claim they need to change even a couple times. So there are many stressors and geographic difference. So queen health, looking at the queen, which one is normal here? Well, it says stubby. So this one is shorter compared to this one, yeah? So this one here, most likely queen cell was short and queen didn't get enough royal jelly, so it didn't grow enough. And as a consequence, a smaller abdomen, it will have smaller ovary, it will be most likely underperforming. It was most likely not bred properly because may not have been very attractive to drones. We don't know whether it has a good pheromone secretion and attraction versus this one here is beautiful, long, slender brunette that will last very nice. And you can see basically background here. These larvae are overfed with royal jelly. This colony is very healthy. This bee is keeping this colony under the check. Magic substance produced by these mandibular glands are abundant here, and it's beautiful colony. That's what you want. You may notice that one wing is shorter. Wow, do we have deformed wing virus here? No, we don't. You can see that it is sharp right wing. It's cut off, and certain people, including us, we are clipping one wing. Why do we are clipping one wing? Because if we don't notice swarm cells and colony goes into swarming, old queens will be leaving hive following the swarm. However, as it flaps the wings, it doesn't go straight because one is shorter. It will not be able to follow. It will fall on the ground. The swarm will station within 100 meters, will realize they don't have queen. They will return back. And these will usually give us additional week to notice queen cells potentially and not lose half of our herd. Some people, specifically Europeans, it's again difference in mentality, different approach, same as spaying or non-spaying cats and animals. Some people feel that this is not really a good management system, clipping wings. But anyway, it works for us. Problem with queens. We have two types of condition of hive. We have queen-right and queen-less colonies. Queen-right colonies have queens. Queen-less colonies don't have queens. So queen-right colony, there are several potential problems with queen. Failing queen, drone layer, over hygienic genetics. So we spoke about this hygienic test. Sometimes, and who is bringing genetics? Queen is bringing genetics. So if the colony is over hygienic, if it removes too much, you don't want that either. And last, and we will not be dwelling on that. Go and read about it. It doesn't happen too often. And currently, with all these big diseases around, sometimes it's okay to have one or two colony that is over hygienic, but the rest are protected. Deployed drone, though, we don't want to have those ones because this means that queen did not have good selection of drones. Queen mated with its brothers or uncles or cousins, and we have too close genetics there. So even though queen is thinking that is laying the fertilized egg, and egg is diploid, but because the genetic similarities and chromosomal similarities is so close that this diploid individual is not going to be worker, but is going to be drone. And worker bees are detecting these early monsters, if you wish, genetic monsters, that they should be workers, but there are chimera and becoming drones. And they're removing these. And again, recognizing the colony, usually it is, you can recognize it, but abundance of eggs, but not enough brood. And both of these conditions will be similar. Read about it or watch some videos. Again, if you have good mating protocols and a lot of drones, you should not have problem with these. So, but we will cover today failing queen, drone layer, emergency cell we already mentioned, and laying worker. So let's start with failing queen. Failing queen, what does it mean? It means that it's either old queen that is 3, 4, 5 years and liquid nitrogen tank. Spermatheca is becoming empty. So again, queen is things that is based on the size of the diameter of the cell measured, saying that worker should be laid there, and it lays worker eggs in her head, but there is no sperm. And even though while is pressing against this duct is coming out from spermatheca, there is no sperm, so egg cannot be fertilized. So basically, we have drones coming out, putting into worker cells. And since worker cells are smaller, what we'll see small drones compared to normal big drones. So we'll see these miniature drones there, abundant of them if this condition goes on. So basically, what workers will notice that, oh, this queen is not good enough, and they will start build supersedure cells out of at least some cells that were properly fertilized. But that's not good. You don't want to keep that queen because genetic of this queen is not good. So you want to requeen it back. At the same time, larvae are healthy and pupae are healthy, because if you have larval that and pupal that, you may have similar conditions. So this is must. You have to rule out disease, and when you rule out infectious disease or brood disease, and you look at the colony, in that case, you can say, okay, this is failing queen. I need to requeen it. How do you see it? Initially, you see drone cells dispersed in the area where you should see only broods, only worker cells. Drone cells, drone brood is usually at the periphery, where they build bigger You can see that these are bigger, these are small. We shouldn't see drones here. And eventually we will see supersedule cells, but queen is still there and still laying eggs. So we know that this is not an emergent replacement of the queen if we still see queen and still see eggs. So here is our diagram from the last session. Swarming cells, we already spoke. It's at the periphery of the frame. If we see at the face of the frame, we know that bees, worker bees are looking for suitable candidate for replacement of this queen that is failing. And there are still some eggs and you still see queen. So this is failing queen. If you see supersedure cells at the face of the frame and you don't see eggs and you don't see queen, it could be that these are emergency replacement queen cells, or it could be that it was failing queen and these just killed it anyway. But if it is emergency queen cell, if these are emergency queen cells and queen was not replaced, or they failed to find proper young worker brood to replace it, suddenly hive will be without queen pheromones. And remember, queen pheromones are this enchanting magic substance that suppresses development of the worker ovary. As soon as it is not there, worker hypoplastic ovary will start develop and some workers will start laying eggs. But as Ivana explained this very good, these workers that lay eggs, the eggs are not fertilized because these workers did not mate and they don't have spermatheca. So we call that condition laying worker or pseudo queen. And again, we see it when queen is killed or replaced, and it's not killed, but it's not replaced by a young queen, and we have prolonged period of the hive without pheromones. This hive is doomed to die because these pseudo queens will lay eggs that are not fertilized, haploid, and drones will come out from them, and lazy drones do nothing. They don't bring propolis, they don't bring nectar. They just wait for worker bees to feed them. And in this particular case, we don't have worker bees because we don't have queen laying fertilized eggs. And if beekeepers notice this, the best approach is probably to shake it, shake the colony, and save at least some worker bees there that will be distributed among neighboring colonies. And pseudo queen, if it wants to come back into colony, will not be allowed by guard bees at the entrance. How do we see it? You can recognize it by multiple eggs in the same cell, and also by cells laid on the side of the cell. So sometimes they're at the bottom if cell is shorter. Remember, the queen, proper queen, has long abdomen. It can stick, long and slender. It can stick. Okay, I'm running out of the time, but I will still keep some dismiss. Only a few more minutes. And so we have multiple eggs. Multiple eggs you can also see occasionally with very young queens if there is not enough support or space. But it's not a good thing. Multiple eggs is never a good thing. But if it's a very young queen, give her some time and give her a chance in case that you don't have a good replacement. Drone laying queen or drone layer is a queen that used to be properly mated, that it had sperm in spermatheca, but may not have enough of it. So if it is younger queen becoming drone layer, it means that it didn't have enough sperm, or it could be exposed to various pathogens or pesticides that decrease mortality of the sperm within this spermatheca, nitrogen tank. Or it could be that it's older queen and just simply running out of the sperm. So drone layer, very similar as to failing queen. We see very similar symptoms, chaotic brood, various ages, drones in the worker brood, and consequently poorly mated queen, old queen, and last one, all of you will see it sooner or later. If the queen dies, let's say, sometimes it happens. So during the, let's say, in our area, Thanksgiving Day, we go there and we are removing the apivar from the colony. All the colony are sealed properly sized, so sometimes it's very difficult to remove lower from the upper super, and we do it by force. We smoke it, and after that we remove it and we put back, and some bees are squeezed and die. If queen happened to be dead because of that, or because of this late fall manipulation, or due to whatever reason that it dies during the fall or winter, there is no way that queen could go on mating flights because drones are not available. So queen will not be mated, and it will show as early spring drone layer. You will see only drone brood there. And again, you deal the same as failing queen as well as worker laying worker. Shake those bees, merge them with other hives, either way. Okay, this should not have been here, but similar signs. If we have failing queen, we shouldn't be seeing eggs on the wall, because we still have queen that has long abdomen and is able to deposit eggs at the bottom of the cell. I will finish with this slide, actually with the next slide. I do have short presentation about it. I'll just summarize it here. And this is geared specifically to veterinarians and those that will be prescribing drugs. So we have very high seasonality of the operation, depending where you are, but it is seasonal. You could be on this in South United States, still going to be seasonal, even though they don't have winter or don't have snow and such harsh condition, but they do have dry seasons, and they have honey flow seasons. So I cannot speak about those, but there are seasons that you can treat colonies, and there are seasons that you should not treat colonies. So during the honey flow, during the summer, there should not be treatment of the honey, because you don't want contamination of the honey. The major treatment is spring and fall. The major thorough exam, 2 thorough exams are during the spring and fall. During the summer, we don't examine these big hives. Again, we examine stunts and poor doing if there are some. And during the winter, once we overwinter, once we give bees enough food, we make sure that they are healthy. And in our environment, very crucial, ventilation, which means that we have bottom and top entrance. There is, the hive will survive. And as long as we also made sure that we removed varroa early in the fall, so we have some bees that don't have heavy viral load, these hive will survive. They are gladiators. They are gladiators, not wonder that we call them superorganisms. And for the people who ask me whether there is overheating at 1 Celsius or whatever low 5 Celsius, in Saskatchewan and prairies, we bundle 4 hives together. So 4 of them are hitting each other, and we do not have problem because they can ventilate if there is issue with temperature. Actually, the optimal temperature is 5 Celsius for them to for winter, because that's the lowest amount of energy that they are going to use, and 5 Celsius environmental temperature will not trigger brood rearing. So during these bees can survive the longest at that. If it is much colder, they will be using a lot of resources from and deplete honey. If it is too warm, they will be pushed to start brood too early potentially. And if we have some very severe colds, we could have cold brood or exposed or chalk brood and various other diseases associated with lower brood exposing to lower temperature. Okay, with this I will finish, and I think we have some time for questions, because we have around, yeah, we have some time for questions for this session. So I will open these and try. Oops, what did I do? Okay. Okay, questions. How about I scroll down? Will an overwinter mated queen kept in a queen hotel be okay as a viable queen? Very good question. Okay, so this is a relay and queen hotel or queen bank. So here is what's happening here. We in temperate climates, what we try to do, we try to have queens generated in our environment and have them ready for early spring when we cannot have queens and we don't have to import queens from other regions to our temperate climate. So will that, I believe we need to do some good studies there. There are some studies that queen will survive in queen banks. I believe it is much better if you can create small nucleuses, and there are mechanisms of doing that, like 5 frame nucleuses will survive relatively well if they are insulated well and have enough food. But if you make them on the 2 supers 5 nucleuses, they will survive even better. Okay, what's the next question? Does supplying, where did it, I lost it. So are the big variation in temperature at the end of the winter, start of the spring bad for the hives? Well, bees are, Western bees are adapted to winters. However, if we have very big variations, yes, and specifically, there are people that at first hot or warmer climates, what they do, they will give pollen patties to stimulate them to start grow before availability of the pollen, and they will start to pour a lot of brood. So we will have potentially, if colder temperatures come and cluster forms, the periphery of the brood will freeze, and we will have some a chalk brood. I don't think that it is devastating issue, but it still is going to be it's not good to stimulate bees too early in the winter to build the colony. Can you review using a brood break? Can you review using the brood break for varroa control? Yes. Okay. There are some approaches. So, for example, if you have a two chamber hive, two brood chamber operation, what if you have strong 2 brood chambers? you basically split them in two and put them in two different bottom boards and put them one beside the other. So one will be queen right, one will be queenless. Queenless will start to build emergency cells and will have emergency queen. During this time, so emergency queen will take 2 weeks to be raised from egg to adult, 15 days, 16 days, and additional 2 weeks will be taken for this queen to be mated. So basically, this colony that was queenless with emergency queen cells is 1 month without brood, 1 month without possibility of varroa to proliferate, because there is no reproductive stage. Entire varroa is in phoretic stage. Ideal time to treat this colony, let's say with oxalic acid, this nucleus. And that's basically what it meant. So you make a break in the brood cycle. Creation of nucleuses is very similar. Breaking in the brood cycle by removing of the drone is the same, very similar idea, except that here we are also using natural attraction of the varroa to the drone. Okay, some random question. To remedy a laying worker hive, would a repeated introduction of open brood eggs frame into the hive over a period of weeks encourage the colony to produce a new cap queen? It depends. It may be too late. It could be that the pseudo queen created its followers and it's subdued to this colony, rest of the colony to serve her. It's much better to shake them and create a new, or merge them with the newspaper. But merging with newspaper, you're risking potential fight with pseudo queen and real queen, as well as pseudo queen followers and real queen followers. If bees do not get an opportunity to cleansing flights in the winter for 2 months, will they develop nosema? No, it depends. I didn't cover that. In northern hemisphere, in temperate climates, we have indoor overwintering. We put bees at 5 Celsius in completely dark environment with high ventilation, enough oxygen, and 5 Celsius. And these bees will not have chance to have cleansing flights. Will they be affected with nosema or not? It is depending what was the nosema load entering into the winter, as well as resistance of the bees or genetics to the nosema, ventilation, and some other things. How about I answer only one more, and next will be next presentation. Okay, how many beekeepers keep bees in temperature control facilities in Canada? What are the advantages and drawbacks? Very, very complicated answer. Personally, I think disadvantage is that bees don't have cleansing flights, but that's my personal opinion. We are going slightly against the nature here. However, there are people who will argue that that's not that this is not important. I would refer you to Dr. Robert Curry from Manitoba. He did quite a few studies on winter overwintering. What is the percentage in Saskatchewan? NIC response or gut response would be 25% would be overwinter inside and 75% outdoors. But I cannot, don't quote me. In Alberta, probably slightly higher proportion indoor. Okay, with this, I will stop.